Assalamualaikum and hi everyone. So there is 4 presenter that will teach you guys in this video, including myself, Muhammad Afiq Akmal bin Zairul, Nik Muhammad Haikal bin Nik Muhammad Nasruddin, Muhammad Shaufi Iman Ilyas bin Samijo, and Muhammad Amirul Ashraf bin Aziz. In this video, we will present to you guys about the chapter 7, which is chi-square test. There are 3 subtopics in this chapter, which is chi-square analysis, goodness of fit test, and test for independence, which is contingency table. Hope you guys can learn something new in this video.
So for the first subtopic for this chapter, which is 7.1, is chi-square analysis. A chi-square with symbol x square statistic is a measure of the difference between the observed and expected frequencies of the outcomes of a set of events or variables. Chi-square is useful for analyzing such differences in categorical variables, especially those nominals in nature. Chi-square depends on the size of the difference between actual and observed value, the degree of freedom, and the sample size. Chi-square can be used to test whether two variables are related or independent from one another. It can also be used to test the goodness of fit between an observed distribution and a theoretical distribution of frequencies. A chi-square test is used in 2 similar but distinct circumstances for estimating how closely an observed distribution matches an expected distribution, which is fitting model. We will refer to this as the goodness of fit test. And the second one for estimating whether two random variables are independent, which is when we are interested in examining the relationship between two or more categorical variables. We will refer this as the independence test. The formula for the chi-square test that will be used is the chi-square equal to summation of observed value minus expected value squared over expected value. So we can know that there are 2 formulas to find the degree of freedom on the question, which is we will use V equal to n minus 1 if expected frequencies can be computed without having to estimate any population parameter. And the second formula is V minus n minus m minus 1 if expected frequencies can be computed only after estimating m population parameters from sample statistic. So for the first example, a poker dealing machine is supposed to deal cards at random, as if from an infinite deck. In a task, you counted 100 and 600 cards and observed the following, which is spades 404 cards, hearts 441 cards, diamonds 402 cards, and clubs 353 cards. Could it be that the suits are equally likely, or are these discrepancies too much to be random? So after we read and understand the question, we need to come up with the hypothesis for this question, which is H0 equal to PH, which is portion of heart, equal to portion of spade, equal to portion of diamond, and equal to portion of clubs. And our H1, which is alternative hypothesis, is PH is not equal to PS, is not equal to PD, and is not equal to PC. And our alpha will be 0.05. After setting up our hypothesis, we need to find our degree of freedom value, which is on this question is V minus 1 is equal to 3, and our alpha is equal to 0.05. After that, we need to complete our table using our formula of chi-square, and we need to find the value of our chi-square for each portion of heart, spade, diamond, and clubs. After that, we need to compute the value of test statistic, which in this question is 7.81, and by using given alpha, which 0.05, we need to find a chi-square on the chi-square table. So the chi-square that we will have is 9.77. Last but not least, we need to conclude our answer, which is chi-square is more than our critical region. So the final answer is we will reject H0.
Now, let's move on to the next topic, which is goodness of fit test. Goodness of fit test can be divided into three subtopics. The first one is testing a discrete uniform distribution as a model. Second, testing binomial distribution as a model. And lastly, testing a normal distribution as a model. Let's start with subtopic of testing a discrete uniform distribution. What is discrete uniform distribution? A discrete uniform distribution refers to a type of statistical and probability distribution where the probability of the occurrence of the event is equally likely and falls with a finite set of values. Example situation of this discrete uniform distribution include rolling a 6-face fair die, flipping a coin, and something else. Example question that related to the subtopic is drawing a die, as I said before. Let's try the example. The question is, the observed frequency for drawing die 150 are shown in the table. Use a 0.025 significant level to test the fairness of the die. So, this question is asking for test a fairness of the die, which is related to our subtopic, which is testing a discrete uniform distribution. To solve this question, there are a few steps that we need to follow. The first step is setting up the hypothesis. In this step, we need to write the H0 equal to 1/6 and H1 not equal to 1/6. Step 2 is computation. The first one of this second step is estimated of value of parameter, if any. So, related to this question, there are no parameters that we need to be estimated because we don't need to calculate any other of element such as mean or standard deviation. Second step of step 2 is computing the expected frequency and the H0. In this step, we need to make a table as shown below so it will be easy for us to calculate. In this table, I is referred to surface of a die, OI is referred to observed frequency, PI is probability to get that number, EI is referred to expected value, and last column is chi-square formula. To calculate EI, we can calculate 150 times 1/6 to get 25 for each expected value. To find the value in the chi-square column, we need to use the chi-square formula to find them, and we can total them to get 4.48. Third step of step 2 is determine of the degree of freedom, which is V. This step, we use the formula V equal to K minus 1. K is referred to the number of surface of a die. So, we get 6 minus 1 equal to 5. So, the degree of freedom is 5. Last step of step 2 is computing the value of a test statistic. This step, we just take the value of we calculated before, which is 4.48. Moving on to step 3, which is using given alpha to find a critical region. In this step, we need to write the formula x power of 2 alpha v and state the information that we have. Remember, alpha is 0.025 and v is the degree of freedom that we calculate just now, which is 5. So, it will be x power of 2 0.0255. Refer to statistic table, we get 12.832. Last step is decision and conclusion. Because of 4.48 less than 12.832, we can conclude that since x power of 2 tests equal to 4.48 less than 12.832, there is insufficient evidence that the null hypothesis can be rejected at 0.025 level of significance. Therefore, the die is a fair die.
Now we are going to continue with testing binomial distribution as a model. This model is to determine whether the predicted probabilities deviate from the observed probabilities in a way that the binomial distribution does not predict. It is denoted by X, approximate binomial, and P. N represents a number of elements, while P represents the probability of success. So let's continue with example. This example asks us to test whether the data provided from the six-sided unbiased dice is suitable for the binomial distribution. So let's check it out. Since the dice is unbiased, we can calculate the probability of getting the odd score by dividing 3 with 6, because the odd score on the dice is 1, 3, and 5. So 3 over 6 is equal to 0.5. Then we can make the hypothesis statement. H null is X approximate binomial for 0.5 is a good model, while alternative hypothesis is X by approximate binomial for 0.5 is not a good model. Then step 2, we are going to calculate the probability of getting the number of odd score at the 4 dice. The formula is here, that is 4cx times 0.5 the power of x times 0.5 to the power of 4 minus x. So you can create the table like this one to ease your calculation. OI is the observed value that has been given in the question. PI is the probability of getting how many odd score on the dice. EI is expected value. At the right column, we calculate the chi-square. The formula is the observed value minus the expected value square over the expected value. At the end, we have to calculate the total of the chi-square. Next, we are going to calculate the degree of freedom. The formula of degree of freedom is k minus 1. K is the number of data. From this question, the data is from 0 to 4, so there are 5 data. We subtract 5 with 1, so we get 4. So we have to find the value of chi-square 0.05 for at the statistical table. So you will get 9.48. The value of the statistic, that is chi-square that have been calculated in the table, is 1.845. From this evaluation, we can make the conclusion, since our calculated test statistic that is 1.845 less than value of critical region of chi-square, that is 9.488. So we fail to reject the H null at 0.05 significant level. So the binomial distribution is a good model for this data. Now we are going to test a normal distribution as a model. This distribution is denoted by X approximate normal, that is N, micro sigma square. Micro represent mean, while sigma square represents variance. Now let's continue with the question on normal distribution as a model. A random sample of 50 customers is chosen and their waiting time X minutes are summarized in table 1. From the table 1, the post office manager believed that the waiting times for the customer can be modeled by normal distribution. Test at 5% significant level whether the manager's belief is true. First of all, you have to find the midpoint because the data given is the group data, so you have to find the midpoint that represent as x, so that we can multiply with frequency to find fx and fx square. Midpoint can be gotten by add the class interval and divide it by 2. For example, for class interval from 0 to 3, add 0 by 3 and then divide it by 2, you can get 1.5. After get the midpoint, multiply it with frequency and to find the fx, and you have to find fx square from frequency and midpoint, so that you can get the summation of fx and fx square. Next, you have to create a hypothesis. For null hypothesis, you can write X approximate normal, micro sigma square is a good model, while for alternative hypothesis, you can write X approximate normal, micro sigma square is not a good model. Next, you have to find the value of mean and standard deviation. For mean, the formula is summation of fx divide by summation of f, so you will get 5.49. For the standard deviation, you will get 2.623. Then you have to find the expected value by multiply 50 with z value. Z value can be found using the formula x minus mean over standard deviation. The value of z you have to find is for x less than 3, x more than 3, less than 5, until x more than 8. After that, you have to find value of statistical value, that I mean chi-square for computation. The formula is observed value minus expected value square divided by expected value, and then you have to calculate the total of the statistical value, that is 5.0871. So we have to find the degree of freedom for the next step. Degree of freedom, we have to subtract k with m and subtract that with 1. M is a number of parameters. We have find 2 parameters at the earliest step, that is we find the value of mean and the value of standard deviation. So 5 minus 2 minus 1, we will get 2. At the table, we have already computed that the total statistical value is 5.0871. The next step is we have to find the critical region, that is the value of chi-square of 0.05 with degree of freedom 2. We have to find the value of that at the statistical table. So we will get the value of 5.991. From those value, we can make the conclusion. Since our chi-square computation, that is 5.0871 less than chi-square at the critical region, that is 5.991, we fail to reject H null at 0.05 significant level. So the data provided in this question are suitable to be represented as normal distribution model.
Hi, I'm Shofi. Today, I would like to teach you about tests for independence with contingency table. Before we go through the learning, we must know the definition of contingency table. In testing whether two events are independent, a contingency table is used to practically summarize the information and compute the expected frequencies and the value of the test statistics. As you can see, this is the formula table for contingency table. The chi-square dependence test can also be used to test the dependence of two variables. The hypotheses are stated as follows. H0, the first variable, is independent of the second variable. H1, the first variable, is dependent of the second variable. There are 5 steps to do contingency table. Here are the example questions for this topic. A study is being conducted to determine whether there is a relationship between jogging and blood pressure. A random sample of 210 subjects is selected and they are classified as shown in the table. Use A equals 0.05. Step 1. Make the hypothesis. H0, the blood pressure of a person does not depend on whether he jogs or not. H1, the blood pressure of a person depends on whether he jogs or not. And step 2, determine the critical value using the formula V equal R minus 1, C minus 1. Step 3, make decision rule. And step 4, compute the test statistic. First, compute for the expected value, then using the formula table of contingency table. Step 5, make the decision. For example, since 6.79 is bigger than 5.991, reject H or. Hence, the blood pressure of a person depends on whether he jogs or not.